See an example on finding effective resistance in a circuit. So here's a question. An ohmmeter is an instrument used for measuring the resistance of a circuit without sources between its two terminals. So here's a circuit. We have node A, B, and C, and we have some resistors connected across these terminal, across this node. So what would be the reading of an ohmmeter connected to A and B? So if we connect an ohmmeter to these 2 points, what would be the reading? So it will give you the effective resistance. So let's assume that a current enters at A and it leaves at B. So where would the current pass in the circuit? So first, when it enters this node, it would go towards a 50 ohm resistor, and then it would go to the 15 ohm resistors, and again it would pass through this point, and when it reaches C, it would go into 3 branches. Okay, and this the current will divide. So part of it will go to the 10 ohm and the 4 ohm resistor. So part of it would go towards the 14 ohm, and this would go in this direction towards the 30 ohm resistor. And this would join again here, and a current will flow in this direction towards the terminal B. So what would be the reading of the ohmmeter connected A and B? So let's redraw this. Okay, so we know that the same current would pass toward it would go to the 15 ohm and the 25 ohm. So the same current, meaning that these two resistors are in series, and the same current would pass from C to these two resistors. So these two are in series. So in series, we have to add their resistances. Let's redraw the circuit. So let's label this A, and here's a 50 ohm resistance, and this is B. Okay, so from A towards C, okay, we have to add these two resistors. From A to C, we have 15 plus 25 ohm. So we have 40 ohm from A to C. Okay, and here again, from C to B, we have a 30. Okay, let's draw this symbol for resistance. Okay, this 30 ohm is from C to B. So one current is flowing inside this one, and one current is flowing from C to this point. Okay, and one current is flowing across this, which is in series. So we can redraw this. So this is a 14 ohm resistance, and it is connected to 8 ohm over here. So this is a 14 ohm, and from C, let's call this point D. Okay, we label it D. So from C to D, we have a 10 plus 4, the 10 plus 4 ohm in series. So it is 14 ohm. So if these two are in parallel, okay, we can redraw this and put these two in parallel. So the circuit will be reduced in this. This is point B, A. Here's a 40 ohm. This is point C. This is a 30 ohm, and from B to D we have 8 ohm resistance. It's called this point D. And now from C to D we have this in parallel, which is, so resistance in parallel would be equal to the product 14 times 14 divided by the sum. Okay, and you will get 7 ohm over here. So this reduces to 7 ohm resistance. So from C to D we have a 7 ohm. So now again, if a current flow in this circuit from A to B, so it will travel here. So same current will flow here. When it reaches C, it would go in 2 different branches, and the same current will flow from C to D and to B. So it is the same current which will pass through the 8 ohm resistor. Therefore, these two are in series. So in series, we add the resistances. So we get 8 plus 7 ohm, which is 15 ohm. So this would be 15 ohm. Let's redraw it again. So this is A, and here's a 50 ohm, and here's a B. We have a 40 ohm resistor to C, and we have 30 ohm, and this is connected to B, and this now has been reduced to 15 ohm. So this is 15 ohm in series. Okay, now if the current enters A and leaves at B, so it will pass through the 50 ohm, and then it will pass to this 40 ohm resistor towards C, and at this point it will divide again. So these two must be in parallel. So these two are in parallel. So we have the product divided by the sum. Okay, and so 30 and 15 ohm would give you 10 ohm resistance. So the effective would give you 10 ohm. Now again, we draw the circuit. The circuit has been reduced. Okay, we have a 40 ohm resistor, and here from C to B, now we have a 10 ohm resistance. Now, if a current enters at A and leaves at B, so it would go in these two different branches, and therefore the same current will pass to the 40 ohm and then to the 10 ohm resistance. So these two are in series. So in series we add the resistances. It is 50 ohm, and again if we redraw this circuit, we'll have it reduced. So from A to B, so this is a 50 ohm, and here this is also 50 ohm. Now these two are in parallel, so we can just write it down that RAB, the resistance between these, they are in parallel, so it is this product divided by the sum, and this will give you 25 resistance, 25 ohm resistance. Okay, let's try the second part, A and C. So now we have to find the resistance from A to C. Again, we have to assume that a current enters at A and leaves at B. So the current will go in the following path. So it will travel towards the 15 ohm and the 25 ohm. So these two must be in series because the same current is traveling in these two resistors, and then the current would go to the 50 ohm resistor and reach terminal B, and from B it will divide, and part of it will go to the 8 ohm resistor, and here again it will divide. So one current will flow across these two. So the same current will pass through these two resistors, meaning that these two are in series. Okay, so this one also is in series, and the current will leave again at C. So let's simplify this circuit. Again, here we have node A, 50 ohm resistance, and this is B, and now this has been reduced. So from A to C we have 25 plus 15, which is 40 ohm resistance. And again here we have 30, here we have 8, here we have 14. So these two are in series, we have to add, so we get also 14 over here. So it is 10 plus the 4 ohm. Okay, now let's redraw this current, assuming that it enters at A and leaves at C. So now the path, the current will divide over here, so some of it will go to B and part of it will travel to the 30 ohm, and here the current will divide. Okay, so there are two branches, these two must be in parallel. So we can reduce this. So in parallel we have 14 multiplied by 14 divided by 14 plus 14, you will get 7 ohm over here. So let's reduce the circuit. So 8. So this has been reduced to 7. We have 30. Here again have 50. Here we have 40. And this is junction C. Okay, now let's redraw the current again. So it enters A and leaves at C. So to go to the 50 and then reach junction B, and we travel in these two branches. Therefore, the same current will travel from B to junction D and to this 7 ohms. So the same current will flow here. These two are in series because the same current will flow. So let's write it series. We have to add their resistances, which is 15 ohm. We redraw this circuit, can simplify it. So we have 15 ohm, and we have a 30 over here. This is B, this is C. 50, and here is A, and this is 40 ohm. So now we redraw the current again. So it enters A and leaves at C. So here the current will go in two different branches, it will divide. Therefore these two are in parallel. So parallel, we have to the product divided by the sum. Okay, and again you will have 10 ohm over here. So if you redraw this, you will have 50, and you will have this 10 ohm, and then this is C, and this is a 40 ohm, and this is again at A. So now if we redraw this, the current enters at A and leaves at C, so it will go toward this branch, so the same current will flow in the 50 ohm and the 10 ohm resistor. So these two are in series since the same current will flow, and we have to add, so 50 plus 10 is 60 ohm, and there is another current flowing in the 40 ohm. Okay, so if we redraw this, we'll have a 60 ohm resistance and the 40 ohm resistance, and this is C and this is A. Therefore, these two are in parallel. We have to take the product and divide by the sum. So RAC would be 60 multiplied by 40 divided by 60 plus 40. And this would give you 24 ohm resistance. So resistance from terminal A to C would be 24 ohm resistance. So now let's try the last example, D and C. So let's try the last example. We have to find resistance between B and C. So we assume a current enters at B and leaves at C. Again, the path that the current will take, so when it enters the node at B, it would have to take three different paths. So one would travel directly from B to C across 30 ohm resistance, and part of it will go to the 50 and the 15 and the 25. So the same current will travel here to the node C, and this part of the current will go to the node D and divide again. The same current will go toward the 4 ohm and the 10 ohm resistance. Okay, so these three resistors are in series, and these two are also in series. So we can simplify the diagram again. So let's write B. So here's a 30 ohm resistance to C. So this, we can replace it by the series resistance. So 50 plus 15 plus 25, which is equal to 50 plus 40, which is 90 ohm. And here is a 8 ohm resistance, and this is node D. And from C to D we have this resistance 14 ohm, and this one is in series. We have to add, so we have 14 ohm over here. Now these two, so let's assume again the current enters here and leaves at C. So it will travel across three different paths. So when it enters node D, it would go in two different branches. Therefore, these two are in parallel. So we can simplify the circuit again. So in parallel, it would be equal to 7. So 14 times 14 divided by 14 plus 14, which is 7 ohm. So this, we can redraw the circuit again. So this is 90, this is 30, this is 8, and here we have the 7 ohm resistance. So this is D, this is C. Again, we draw the current direction, so it enters B and leaves at C. So the three different paths would be here, and the same current will travel along 8 ohm resistance and goes along the 7 ohm resistance. So these two are in series. So 8 plus 7 is 15. So we can redraw this circuit and replace it by 15. So we have 30 over here. This is node B and this is node C. And this is 90. So now we have three resistors in parallel. So we can work out first these two in parallel and then we work the rest. So let's work this out. 90 times 30 divided by 90 plus 30. So you will get 45 over 2. Okay, so you can just replace these two by 45 over 2. 45 over 2 ohm, and we have the 15 ohm. Now these two are in parallel. We have to work this out in parallel. So we have O BC is equal to the product over the sum. And when you work this out, you must get 9 ohm resistance. So the resistance across BC is 9 ohm.